All right, now we need to think about storage. Is this model a good model for storing the data in this application? Let's find out. So let's talk about the users and permissions. First, we're going to specify the type of the relationship between these two entities. Here we have a many-to-many relationship because a user can have multiple permissions and the same permission can be applied to different users, many-to-many. But there is a problem in this model. The problem is that every time we register a user, we have to explicitly assign those permissions to that user. For example, today we have one cashier, let's call it cashier number 1. We need to give this cashier 10 permissions. Tomorrow we hire a new cashier. We have to come back and give this new cashier these exact 10 permissions. The problem here is that we may give one cashier an extra permission, or we may forget to give them one permission that they really need. So the issue is that our cashiers or store managers are not going to have a consistent set of permissions. Each user has different set of permissions. So we have to make sure that our users have consistent permissions. Now back to our requirements document. Nowhere in this document we were asked for the flexibility to assign specific permissions to each user. So this model is too fine-grained for this application. It's suitable for an application where we want to have full control over the permissions of each user. So we need to change this model and introduce a new entity called role. We want to put our users in roles or groups like store manager or cashier, and then assign permissions to those groups. Next time we register a new user, we simply add that user to a specific group or role, and that user will automatically inherit all the permissions in that role. With this change, our users will have a consistent set of permissions. So let's add a new entity here. All right, so here's our new entity, role. Each role should have a name. Now we need to assign a user to a role. So let me move this relationship to here. A user belongs to one role. We don't want to add users in multiple roles because nowhere in the requirements we were asked to do so. So let's change this end of the relationship to 1. That is probably the drop-down list on the right side. Let's take a look. That was right. So a role can have multiple users, but a user belongs to one and only one role. Beautiful. Now we need to add a many-to-many relationship between roles and permissions. A role can have multiple permissions, and a permission can belong to multiple roles. But before we do this, let's go back to the requirements document and have a closer look at the kind of permissions we need here. Basically, we have the store manager that can do everything, and we have cashier that can do everything except managing the list of movies. So the cashier can only view the list of movies. They cannot add, update, or delete a movie. That is the only difference. So in my opinion, this model is a little bit too fine-grained and too specific for this kind of requirement. We don't really need a table like permissions with records like add movie, update movie, delete movie, add customer, update customer, delete customer. This is very fine-grained. We don't want that level of control. For example, we don't want to have a role where a user can add a movie but not update a movie. See where I'm going with this? We don't need that level of control here. So in my opinion, we really don't need this entity. All we need to know is the role of the user. And in our application, we can write a simple if statement. If the user is a store manager, we will enable all features. Otherwise, if they are a cashier, perhaps we're going to hide certain features or disable them, like adding a movie, updating a movie, and deleting a movie. That's all we need, nothing more. So let me give you a metaphor. Imagine you're traveling and you need one room to stay for one night, and your budget is $100. Let's say you're a single person. All you need is a simple room with a single bed. Now you come to me and I say, hey, I have a room. It's actually a suite. It's huge. It has a king size bed. It has the view of the ocean. It has a balcony. It has jacuzzi. It has Wi-Fi and video games, but it costs you $500 a night. Would you pay for that room? You probably wouldn't. All you need is a simple room to stay for one night and your budget is $100. You're not going to spend extra $400 for the features you don't need. Building software is the same. All these additional features that you predict that may happen in the future, somebody is going to pay for it. That is the company. So don't over-engineer. Don't ruin people's money because of the features that you think are necessary. Now, this is not all about money. It's about managing complexity. In this design, I don't want to bring extra complexity because this complexity is going to stay there for the lifetime of this application. Every time we need to fix a bug or introduce a new feature, we'll have to deal with unnecessary complexity that inexperienced people have brought into the design of this application. So let's delete the permission entity here. We don't really need it. All we need is a simple role table. Now, let's set the data types. Both the username and password are going to be a string. The name of the role should also be a string. Beautiful. Now, for the customer, these are all strings, so I'm not going to waste your time typing them. Barcode is going to be a string because we're dealing with a 10-digit number. Daily rental rate is going to be a float because you might have a number after decimal point. So let's set that here. Number in stock is going to be an integer. Now, when it comes to building a physical model, we're not going to use the integer data type in MySQL because that would allow us to store up to 2 billion. We're not going to have 2 billion copies of a movie in a store. So the maximum number we need here is probably 50 or 100. We can use a tiny int for that. Now let's look at the rental. We need to know the number of days. Here I'm going to remove this attribute and replace it with 2 date time attributes. The date somebody rented a movie and the date they returned it. With this, we can calculate the revenue per month, per day, and per year. That was one of our requirements. With this design, we cannot calculate the rent for a given time period. So let's break this into 2 attributes. Let's say rent date and return date. Both are either date time or date. I don't think in this domain we care about the time. Perhaps the date is sufficient. Now we can subtract these 2 values and calculate the number of days. Now, each rental can have a maximum of 1 coupon. So this end of the relationship should be 0 or 1. So I'm going to select this relationship and then change the right end to 0 to 1. So here's the icon. That is 0 to 1. Now in physical terms, in a physical model, that means we're going to have a table called rentals. In that table, we're going to have a column called coupon, and this column is going to be nullable. Okay? So a rental can have a maximum of 1 coupon, but a coupon can be applied to many different rentals. Beautiful. Now, what about the relationship between the rental and the movie? Each rental is for one and only one movie, but the movie can be part of many different rentals. So this end of the relationship should be 1. Let's set that here. I'm not entirely sure if it's the left one or the right one. It depends on how I inserted the relationship. All right, that worked. So we have a one-to-many relationship between the movie and the rental. By the same token, a rental is for a specific customer, but a customer can have multiple rentals. So this end of the relationship should be 1. Let's set that here as well. There you go. So one-to-many. Also, here in the customer entity, I'm going to break the name attribute to first and last names. That is better. So we're done with our logical model. Now I leave it up to you to build a physical model for this in MySQL.